Good morning, students. Since till now we have studied about reflection, which was the first part of the chapter, light. Now today we are going to start refraction. It is the second part of the light chapter. In reflection, what we have studied, that light travels in its own medium after reflection. What you have studied till now. This is the plane mirror, and incident light falls obliquely on any plane mirror and reflects in its own medium by making angle I equals to angle R for reflection. Now in refraction, what you will study, that this is one medium and this is medium 2. Here light will fall obliquely from one medium and it refracts in another medium. That is bending of light from one medium to another medium. So let's now talk about refraction completely. What is refraction? That is, refraction is that when light bends from one medium to another medium is called refraction, or you can say the bending of light from one medium to another medium is called refraction. So this is we call refraction. Similarly, what you have studied in reflection about laws, here also we will study about laws. Let's now study about laws of refraction. So first of all, for complete knowledge, see, this is medium 1 and this is medium 2. What happens? Light falls obliquely from one medium, and by making normal, it bends in another medium. So here, the first medium from where light is coming, this is called rarer, and in another medium which is called denser. If we talk about rarer medium, just like air is a rarer medium because here particles are free to move, whereas in denser medium what you see, that the molecules are dense, such as liquid, water, anything, glass. It is a solid part or liquid part because the particles are free but they are dense. That is why we see it is a denser medium. So light travels from one medium to another medium is called refraction. Now here see, when light comes from one medium to another medium, this light is called incident ray and this ray is called refracted ray. Now see, this dotted line is called normal ray. The angle between incident ray and refracted ray is called angle of incident, and this angle is called angle of refraction. So here what we have studied, that light travels from one medium to another medium, that is from rarer to denser. We see it bends towards the normal, and the coming light is called incident ray. The light which refracts from its point is called refracted ray. Now, these are the parts of refraction. Now let us study how refraction takes place by using a glass slab. Before we see glass slab refraction, let us study first laws of refraction. On which law does refraction works? As we have studied in reflection, there are two laws. First law, and there we have studied that angle of incident, incident ray, refracted ray, and the reflected ray and the normal all lies on same plane. Here also the same thing happens. The incident ray, the refracted ray, and the normal ray all lies on the same plane called point of incidence. Second law we know, Snell's law. Snell's law means the ratio of angle of incident to the angle of refraction. Snell's law states that the ratio of sine means the cos angle sine theta cos theta, that sine of angle of incident to the sine of angle of refraction, that is sine I upon sine r. This will be the constant value, so it is given as Snell's law. So these are the two laws on which refraction is based. Now let us study about refraction through plane mirror. Refraction through glass slab. How you see glass slab? Glass slab looks like a cuboid of which is made up of glass. It looks like this. एक ग्लास का होता है कांच की तरह, और एक साबुन के जैसा होता है, जैसे उसका शेप आप देखते हो. इट इज द फॉर्म ऑफ क्यूबॉइड. Here you see it is a form of cuboid. This is known as glass slab. Here what we see first, experimentally it has done that. Let us study first diagram, then we will discuss about the experiment. This is your glass slab. Now ray comes from one medium. This is medium air, that is called medium 1. This is glass, medium 2, and again this is air. Light falls obliquely on glass. It falls obliquely on glass, and by making normal, it refracts. After refraction, it moves towards another edge of the glass slab. Then again it makes normal, and again it refracts. What we see, the refraction is occurring two times. Here also, from air to glass and from glass to air. Now what happens? What we see? Here we see this is the rarer medium, this is denser medium, and this is again rarer medium. Now let us discuss when light travels from rarer to denser. When light travels from rarer to denser, it moves towards the normal. This is your normal, and its lights bend towards the normal. That is rarer to denser towards the normal, and from denser to rarer, see here, from denser to rarer, light is moving away from the normal. away from the normal. That is what we see. That is, when rarer to denser, it moves towards the normal, and from denser to rarer, it moves away from the normal. So, if we draw the original ray from the incident ray, we get the parallel rays. So, this is the parallel ray. What we see, that the ray which is falling obliquely on the glass is called incident ray. This is first normal, n1 dash. This ray is called refracted ray, and this ray is called emergent ray. See, let us mark as point A, B, C and D. So AB is incident ray, BC is refracted ray, and CD is emergent ray. Since if we talk about these two mediums, then this is incident ray, this is the refracted ray, and if we talk about these two parts, these two mediums, that is, then this is called, BC is called incident and CD is refracted. That is, in both the cases, these two are the refracted rays, but we know when light comes from denser to rarer, we call as emergent ray. If we draw a line parallel to CD, what we see, this is the original ray. And the distance between these two lines, the emergent ray and the original ray, we say lateral displacement or lateral shift. Okay. Now, the angle between first normal and the incident ray is called angle of incidence. The angle between normal and the refracted ray is called refracted ray, R, and the angle between second normal, N2 dash, and the emergent ray is called angle of emergence. See, now we will talk about here that the incident ray and the refracted ray here will never be equal. Angle I is never be equals to angle R, but angle I is nearly equals to angle E. Both will be nearly equals to same. So this is the refraction part, and now we will discuss about refraction through glass slab. As we have know right now that glass slab is a cube of cuboid like of glass, made of glass, whose edges are equal in size. We will not take a glass, any glass, but we will take a thick glass. You will do, if you do practicals in your school. Right now there is no practicals and no schools because you all are studying at home due to lockdown. Now here we will discuss about the refraction through glass slab experiment, how experiment is done. So this experiment is done like, we will take a wooden card और वुडन बेस, ठीक है, आप एक वुडन बेस लोगे तो वहाँ पे क्या करोगे, एंड यू नीड अ A4 साइज पेपर, A4 साइज शीट, ग्लास स्लैब, पेन्स, पेपर पेन्स, पेंसिल, scale, these all things you will need. Now first what we will do, we will place a A4 size sheet on that wooden block. This is my A4 size sheet I have placed on the wooden block. Now this is my A4 sheet, no? This is my wooden block and this is my A4 sheet. The diagram will be too small that you will not able to see. So this is my A4 sheet and this is my wooden block. This is my wooden block and this is my A4 sheet. Okay. We will place pins at the corners so that the paper will not be float in air. Now place a glass slab at the center of the paper. You will place a glass slab and mark its corners by using a pencil. Put your glass slab and mark as this. Now if you remove this glass slab from the paper, note that you should keep it properly on the paper so that the ray diagram when you will draw, that should not be disturbed. Now take two paper pins and put obliquely in manner from head to head. See these two pins, let this pins be pin 1 and pin 2. I have put it on the paper, and now do these two pins in a straight line manner from the other side of the glass slab. Now what you will see from other side of the glass slab, you will mark these two pins from head to head. That is, if you place a pinhole camera, what you will see that you lit a candle. So what you see, these all candles are in straight line. That is from that phenomenon, from that concept. Here also you will do that. You will place another two pins from other side of the glass slab from your eye. We are looking from here, this side. So what you will observe, we will observe these two pins and are head to head. They are arranged head to head. Now remove all the pins. You will remove all the pins and mark the points. By marking these points, you will draw a line. This is the ABCD is your glass slab, and now we are marking a point. This we will get. We make normal. Again we will mark these points. We will make again normal for this. These two are normal, and we will join this line from end to end. Okay. So what we have observed that when light travels from one medium to another medium, it bends. This is experimentally you have proved, where there you have studied, now here you are proving. So as usual, we know this is the incident ray. Mark X, Y, Z, P. So